Hey everybody, Melissa here from Stahl Sava Industries. Today, we'll be discussing one of the most common manual manufacturing operations, using a hand tool to apply cable crimp sleeves, or ferrules, to a length of wire rope or miniature mechanical cable. Now, before we dive into crimp sleeves, it's important to begin this conversation by understanding the value of hand tools to produce mechanical cable assemblies. Hand tools are great for prototyping, or when you have small production runs that don't require a machine press to achieve a more precise mating of components. Sava manufactures two different hand tools that serve this function, the T185 and the T188. The T188's larger handles allow for increased leverage when crimping a ferrule onto a fixed length of mechanical cable. So, let's get into what cable crimp sleeves, or ferrules, are. Ferrules, which are synonymous with cable crimp sleeves, is a cable fitting that's crimped or pressed onto wire rope to achieve a looped end, or in lap splicing designs, pairing two separate cables together. Cable crimp sleeves come in various geometries, including a figure 8, ovular, or cylindrical, and each has specific uses. Ferrules are made from various materials, such as zinc-plated copper, aluminum, stainless steel, and brass. And, as you can probably imagine, each possess its own advantages and disadvantages. For instance, take stainless steel ferrules. They're incredibly strong and highly resistant to both rust and other kinds of corrosion. However, their hardness makes them less malleable, which in turn makes them incompatible with hand tools. And even when a stainless steel crimp sleeve is small enough to fit properly within the cavity of the hand tool, you may damage the geometry of the crimp sleeve and subsequently the entire cable assembly. On the other hand, materials such as zinc-plated copper, aluminum, and brass may not boast the same strength as stainless steel, but their high malleability makes them well suited to hand tools. Now, it's critical to pair the correct cable with the appropriate crimp sleeve. Incompatible combinations can result in insufficient contact, potentially leading to failure of the cable assembly. Today, we'll demonstrate creating a looped configuration using our T188 crimping tool and an aluminum loop sleeve. If you want more information on our crimping tools, go to savacable.com/tools. Looping configurations are a rather simple manual manufacturing operation. First, insert the length of cable into one side of the ferrule's through hole. This operation alone is made easier in cable crimp sleeves that are figure 8 shaped because the center of the 8 separates the through hole effectively into two distinct slots. Be sure to initially feed enough cable through the through hole to allow the cable to return through the remaining vacancy in the fitting. Being mindful that mechanically cut cable may deform or fray the wires, carefully insert the pulled through cable back into the remaining through hole to form a loop. With a loop slackly assembled, one can now size the loop to the drawing's requirements by pushing or pulling on the long end of the cable until the desired loop size is achieved. It is recommended that a small amount of cable protrudes out of the completed end of the loop to ensure that when pressed, the cable's wires naturally expand outside of the cable ferrule. This tail provides additional strength to the assembly. Once the loop size and the tail are set to their proper orientation, crimping the fitting to the cable takes place. To do this, one inserts the cable ferrule fitting into the compatible vacant cavity of the tool itself. In some cases, the geometry of the cable ferrule informs how to insert the fitting. In figure 8 cable crimp sleeves, for instance, the fitting is turned laterally onto its side so that the left and right sides of the fitting and loop are making direct contact with the walls of the cavity. This configuration assures that each side of the assembly's loop are pressed within the tool. Tilting the figure 8 cable ferrule flat inside the cavity would mean the ferrule is not oriented soundly in the space allocated, and forces applied to the pressing operation would not sufficiently compress the loop to the fitting. With the cable crimp sleeve seated snugly in the cavity, the operator firmly grasps both ends of the hand tool and applies manual force to close the head of the cavity. This operation should be repeated along the entire length of the cable ferrule fitting until the entire fitting is formed to its new mated geometry. In Sava's T188 hand crimping tool, the larger of the two available, the tool comes with a go gauge, which is a small hand measuring tool that helps the operator validate this manual manufacturing operation. What's more, pull tests should be undertaken to ensure the required factor of safety has been met, one assembled cable part to the next. Lap splicing is essentially the pairing of two separate lengths of cable by a ferrule sleeve. This lapping operation is achieved when each of the two lengths of cable are overlapping one another using a cable crimp sleeve fitting. In this manufacturing operation, commonly more than one cable ferrule is used in this configuration to ensure sufficient strength is achieved at the joining point, similar to loop configurations inasmuch as one is feeding the cable into the through hole of the cable ferrule. In this configuration, one feeds the cable through two or more ferrules in each direction, thus pairing two separate lengths of cable from opposite directions. It is more important to leave a small space between the two or more cable crimp sleeve fittings because as the pressing operation is executed, the ferrules naturally undergo elongation. Omitting the space necessary to allow for each fitting to slightly expand means the ferrules may collide with one another, potentially compromising strength and flexibility. Providing one accounts for these unique application considerations, one can proceed by simply referring to the previous 5-step process to complete the manual pressing operation. While hand tools are great for certain applications, there are situations where an industrial press is more suitable. For a complete list of our products, please visit savacable.com, leave any questions or ideas in the comments. You can find us anywhere on social media, and remember, Sava has a full machining department that can custom manufacture just about anything. Let us know how we can help you. Thanks!